All right, we have some different words to describe species decline and loss. Extinction means the entire species is gone, or sometimes we say it's functionally extinct if there's only a few individuals left that maybe exist only in zoos, and there's no chance this population is going to ever recover. That's extinction. Extirpation means that it's gone from one environment, but it might still be abundant in another environment. In northern Illinois, the cricket frog used to be very abundant, and during the 1960s, 70s, and 80s, it declined until it was completely extirpated from the Chicago area and most of northern Illinois, although it's still abundant in southern Illinois. So the species itself isn't experiencing a problem, but it was extirpated from the Chicago area. Endangered means in danger of being extinct. So an endangered species is one that could still recover. Numbers are declining. There's habitat loss, overhunting, whatever's causing the numbers to decline. But it's not extinct yet, or functionally extinct. Threatened is the next level up. So if it's threatened, that means it's not endangered yet, but its numbers are declining, and or habitat is being lost, and it is possibly going to end up as endangered or extinct. A mass extinction, there have been 5 large mass extinctions during the history of Earth. Well, the one that you've probably heard of is the extinction of the dinosaurs 65 million years ago that was caused by an asteroid strike. A mass extinction is when huge numbers of species go extinct in a very short amount of time. Some people argue that we are currently in a 6th mass extinction caused by human habitat destruction and climate change. I think it's still debatable at this point whether that's certain or not. Certainly the level of more species are going extinct right now. That is absolutely true. Whether it's gotten to the level yet where we could call it a 6th mass extinction, I think that's arguable still at this point. Some recent extinctions in the Americas. The ivory-billed woodpecker was a very large woodpecker. It's about the size of a seagull, very large, lived in old-growth forests. All of the old-growth forests east of the Rocky Mountains have been slowly logged over the last 300 years until there was absolutely none left. And this woodpecker needed to eat insects that existed only in these old-growth forests. And the last patch of old-growth forest where it lived in Georgia was logged famously by the Singer Sewing Machine Company in the 1940s to make wooden cabinets for their Singer sewing machines. And that's the last time any ivory-billed woodpeckers have been seen. Although there have been some individuals in the last 10 years or so who've claimed to have seen or heard them in the wild, those sightings have not been verified. The passenger pigeon, which used to exist by the tens of millions in North America, the flocks were so huge they would take all day to fly over particular areas. It was hunted with shotguns. They were so dense that people said you could fire a shotgun one time and bring down 20 birds. People ate them. They're pretty small for meat size, but you know, tastes were different back then. And they were hunted almost to extinction. So when the passenger pigeons stopped being hunted, there were still hundreds of them left, but because they were a species that relied on these huge flock sizes as part of their survival, once they were reduced to small numbers, they didn't survive. And this, of course, this picture here, this is not a live bird. This is a stuffed bird that's in a museum. They went extinct before color photography, so this is not a a picture of a living passenger pigeon. Although we have so many specimens, this is one that it might be possible to bring back through genetic engineering, as we have so many preserved remains. The Caribbean monk seal went extinct over 100 years ago. It was hunted to extinction by sailors. It was pretty fearless. Sailors could walk right up to them and kill them. And, you know, they were several hundred pounds of meat. So they were hunted to extinction. The Carolina parakeet, and again, this is not a live bird. This is a stuffed museum specimen. They went extinct due to habitat loss. They used to live on the east coast of the United States in forests. And again, this was a species like the ivory-billed woodpecker that lived in old-growth forests. And so once the last remnants of the old-growth forests were logged, the Carolina parakeet went extinct. It needed large trees for both food and for nesting sites and did not adapt well to second growth forests that are abundant now. And, you know, a lot of people think that these sorts of extinctions are modern phenomena, that it's only Western industrialized societies that are causing extinctions. But in fact, our species has been causing extinctions for tens of thousands of years, if not millions of years. And going all the way back to our species' origination in Africa, there is evidence that starting 3 million years ago, when Australopithecines and the first members of our genus appeared, that there were already detectable extinction events happening in Africa where our species was. And in fact, it's thought to trace to our species first beginning to switch from scavenging to hunting about 3 million years ago. Or not our species ancestors. And in fact, since the origin of our species itself, 200,000, 250,000 years ago or so in Africa, many large mammals went extinct at that time. About 18% of large mammals went extinct. Now, as our species has migrated elsewhere on the planet to Asia, Europe, and Australia, to islands, and then finally to North America, as our species migrated, large huntable sized animals went extinct, especially things that were over 20 pounds. Things over 50 pounds went extinct first, and then things 20 pounds and up started to be affected as well. So, and we'll talk about some of those examples of large extinct animals due to our species. Flightless birds were hunted to extinction, and these we know they were hunted by humans to extinction because bones with butcher marks have been found on them, smashed eggs have been found, and some were modern enough to be in historic times, like the extinction of the dodo bird on the island of Mauritius. The dodo bird was a turkey-sized bird that was a flightless bird that lived on an island, and sailors quickly discovered that it was easy meat that they could stop and get. And in fact, we still have the word dodo here, meaning that somebody who's a dummy, because the dodos were fearless of humans. They had no predators on the island that they lived on, and so people could just walk right up to them and grab them. The elephant bird of Madagascar in myth is called the roc, R-O-C. You may have heard that. And it was long thought to be just a mythological bird until remains were discovered. And in fact, the elephant bird went extinct shortly after humans showed up on the island of Madagascar, which is off the east coast of Africa. New Zealand had moas, and there were several species of giant flightless birds, and they were all very quickly hunted to extinction by humans when they showed up, because probably like other animals, as our species has migrated around the planet, every place our species went, we discovered fearless animals who had never encountered a primate predator before and were unafraid and were easy to hunt. Species in Africa are much more wary of humans. They evolved with humans as hunters and are much harder for humans to get close to because they are instinctively fearful of us. But other places in the world, not so much. North American mammals that went extinct after humans showed up. So humans did not show up in North America until very late in our migration. At least by 16,000 or so years ago, there was definitely humans in North and South America. Some can push that back to 20,000 years ago. There's even a little bit of tantalizing evidence from South America that are even older than 20,000 years old. But after humans showed up, large mammals started to go extinct. And the environment was changing at that time. The Ice Age ended about 10,000 years ago. So you could certainly argue that mammoths went extinct because of the changing environment. The kind of steppe that they lived in disappeared from most of North America and is now found, the environment where the mammoths live, that type of environment is now only found in northern Canada. But other species like the Yukon horse, which disappeared, the horses today certainly have gone wild and are feral in the western United States. So it's hard to argue that a very closely related species went extinct because of the changing environment, when apparently the environment today is perfectly good for wild horses. Similarly, there was a large wild pig-like animal, the California tapir, went extinct as well after humans showed up. This is, of course, not a picture of the extinct California tapir. This is a similar animal that still lives today. But wild pigs certainly have no trouble at all living in the same environment today. So although you could argue mammoths went extinct maybe partially from hunting, partially from environmental change, the giant sloth as well, maybe partially from environmental change. It's hard to argue that humans had no effect on the extinction of these types of animals, and there are others as well. So our species has always helped other species go extinct. It's not new. It's not something that's only a trait of modern industrial societies. So we'll talk about each of these as causes of biodiversity loss: habitat loss, pollution, overharvesting, invasive species, which this is because we are a mobile population. We bring things with us as we travel around the world, intentionally or unintentionally. And then we'll also talk about climate change. So habitat loss, there are several reasons for habitat loss. One is just for human housing or humans growing crops. Generally when we grow crops, we completely eliminate the natural ecosystem that was there and completely replace it with whatever plants we're growing. We also just harvest natural resources, either wood or diverting water for crops, which destroys wetlands and riverine environments. Those are reasons for habitat destruction. For organisms that happen to live in a forest where we want to harvest the lumber, or animals that live in an environment where that would be good for farming on arable land, they are removed by our activities. Arable land is farmable land. Arable land includes land that's suitable for growing crops and also land that's suitable as rangeland. So rangeland is land that's suitable only for growing grasses. So rangeland would be good for grazing animals, but you couldn't grow crops there very well without irrigation because it's too dry generally. But that's arable land. So most arable land is what we would call rangeland, and less than half of it would be farmable to grow crops without irrigation. And that's the land that has suffered the most. So temperate grassland is the favorite farmland because you don't have to clear trees from it. It generally has, especially like tall grass prairie, the Midwest tall grass prairie that existed here. Lacey, stop that. Tall grass prairie had more rainfall, was perfect for growing crops. You didn't have to clear forest in order to farm it. And so as a consequence, tall grass prairie in the United States is almost completely gone. It's 98% gone and converted to farmland. Short grass prairie has also suffered, but it is drier. So there's some crops you can't grow easily on the shorter, where there's less rainfall, the short grass prairie. So there's more of that left. Some of it was, they attempted to farm it and then it was abandoned because there's simply not enough rainfall without irrigation. Chaparral is dry forest like what they have in California, and the Mediterranean is chaparral. Temperate deciduous forest, more rainfall, really good for farmland, but it's forest. You got to clear it in order to farm it. So that's what puts that down in desirability. But nevertheless, a lot of temperate deciduous forest was cleared in the United States for farmland. Any farmland on the east coast of the United States was temperate deciduous forest, and it was cleared for farmland. Tropical dry forest, also good for farmland. Savanna, not so much. This savanna is tropical dry grassland, so not as good. Generally need irrigation. Desert, again, there's enough sun, not enough water, so you have to irrigate to grow crops in the desert, like you do in savanna. Tropical rainforest, again, got to clear it, although a lot of it has been cleared for farmland. And then boreal forest, almost completely untouched because it's too cold to grow crops and it's only harvested for lumber. Tundra, completely unsuitable for growing crops, so untouched. Overharvesting is a huge problem as well. Overharvesting wild organisms. This is the main reason why rhinoceros are almost extinct, is because of harvesting them specifically for their horns. Elephants almost went extinct specifically because of harvesting them for their tusks. Bears for their bile. So that's a huge problem. And also wild animals being harvested for food is also a huge problem, especially if they're already rare. Fish populations have declined precipitously since industrial fishing methods have come online in the last 150 years. When people compare descriptions of fish populations 200-300 years ago to fish populations today, it's quite clear that conditions were very different hundreds of years ago when humans first started massive fishing efforts. In the 18th century, people described whale populations as being so huge that they seemed infinite and like an inexhaustible resource. And we went from that to 100 years later, causing the extinction of various species and bringing many other species to the brink of extinction. Sea turtles were described as being so numerous by naturalists that as they were trying to come ashore to lay their eggs, that their shells seemed to make a continuous surface miles from the shore. And that they, one naturalist remarked that he thought he could get off of his ship and walk several miles to the shore just stepping on the turtle's shells. Of course, that wouldn't actually work, but that's how numerous they were. So just having documented wild populations in the last 100 years or so, we're missing a huge part of the picture. We're missing a huge part of the decline in marine populations that occurred before we started really documenting and trying to estimate population sizes. when population sizes seemed infinite, there seemed no reason to document them. We didn't start to document them until they were obviously declining and disappearing. Invasive species are another huge problem. Here's just a few of them. The cane toad is famously invasive in Hawaii and in Australia. It was thought to have been a good natural control for the sugarcane beetle, which is why it's called the cane toad. And it turns out to be a really bad idea to introduce new species as pest control without first testing that. Cane toads are an enormous problem in Australia. There's several really good documentaries on that if you're interested in that topic. Burmese pythons, which grow to be enormous in size and can consume prey that weigh over 100 pounds, are now reproducing in Florida, especially in the southern half of the state. They are not very cold tolerant though, so there's hope that they won't migrate further north. The emerald ash borer that was introduced from China accidentally, probably in wooden shipping pallets, has decimated the ash tree populations in the Midwest and probably is here to stay. Kudzu, which was a Japanese ornamental plant that was brought to the United States for people's gardens, turned out to be hugely invasive here because nothing eats it. And that's one of the things, this what you see here in this picture, these lumps, those are trees that have been overgrown by the kudzu. And that's one of the problems when you bring in a new species. They can experience exponential growth because they lack predators, because it's a new environment for them. They will use the available resources and sometimes push out native species because of that lack of predators in the new environment. Some species we have inadvertently benefited just by the environment that we create in our towns and cities. Rock pigeons, otherwise known as just ordinary city pigeons now, used to live only in rocky cliffs in Western Europe. They don't build nests and they're very vulnerable to predators, so they can only reproduce if there are cliff ledges where they can lay their eggs, and they just lay their eggs on a bare ledge. Well, when humans started building large buildings, these are artificial rock cliffs, and the pigeons became abundant. Pigeons have become abundant everywhere where it's not a tropical climate because of our tall artificial modern buildings that are the perfect nesting place for rock pigeons. So their population has increased in the last 500 years thanks to humans. Rats as well. There's two species of rats that move around with humans, the brown rats in more temperate regions and the black rat in tropical regions. And they go every place that we go. They are very well adapted to live on our remains, live in our buildings. They're nocturnal, so we often don't see them. They travel in ships, and they're especially found in the U.S. in pretty much every single port city, like Chicago, Boston, San Francisco, Seattle, all have rats. And there's some notion that maybe early humans actually brought rats with them intentionally, especially to island environments, because you can eat them. So they would let them go, and the rats would eat what was available, and then they could catch them and eat them. Starlings were intentionally introduced over 100 years ago by somebody who wanted to introduce to the United States every species of bird that's mentioned in a Shakespeare play. And the starling is the only one that took off. And it has partially taken up the niche left available by the extinct passenger pigeon. So an available niche was there, the passenger pigeon was going extinct, starlings increased in population as a result to take up those resources that the passenger pigeon no longer was. Okay, let's talk about killer bees. It's one of my favorite stories about good scientific intentions gone wrong. It started out with a great idea. A scientist in Brazil wanted to create a domestic honeybee strain that could live in Brazil in a tropical environment. European honeybees cannot survive in Brazil. So his idea was to take an African honeybee, which are not domesticated, they're wild bees, but they produce a lot of honey and they can survive in a tropical environment, and cross them with a European domestic bee. And his idea was to get a hybrid bee that would have both the ability to survive in a tropical climate and be a good honey producer like the European domestic bee. The general idea that people got from this was that these African bees, they generally call the killer bees Africanized bees. Well, these African wild bees are not super aggressive. People harvest honey from them. They use smoke and climb the trees and smoke the bees to calm them down, just like we do for domestic honeybees, and harvest honey from the wild bees. They're not super aggressive. But when he brought back 9 queens from Tanzania, one of the queens he noticed, because he had them all in little transport boxes, little wooden boxes. One of the queens was extremely aggressive, and if that queen could see him at all, she would behave unlike the other bees and behave in an extremely aggressive manner, which he thought was unusual that 1 out of the 9 behaved that way. But where the bad decision came in was he decided to go ahead and use that aggressive bee in his breeding experiments. Well, he only had 9 queen bees, so maybe that was why. He didn't want to eliminate 1. So he set up experimental hives with each of the 9 Tanzanian queens that he had collected and domestic honeybee males. And one of his students accidentally removed the restrictor. They have a little thing that they put on hives to keep the queen from getting out. It's a little restrictor that makes the hole really small so that the worker bees can get in and out, but the queen can't get out because she's too big. And normally for European honeybees, you can take that restrictor off once the queen starts laying eggs because she'll never leave the hive again. But for the Tanzanian queen, when that restrictor was removed, she flew off into the forest with her followers, her female workers, which is something a European honeybee queen would never do. Once they start laying eggs, they don't leave the hive. When a swarm happens with European honeybees, that's new queens. That's freshly fledged queens who will take part of the hive and go somewhere else. So this was surprising, but they weren't too concerned about this queen flying off. Well, unfortunately, her extremely aggressive behavior was due to a genetic mutation, and it was a heritable trait that was then passed on to all of her offspring because for bees, all of the worker bees are daughters of the queen, and as well as males that are going to be created are also offspring of that one queen. So this trait remained. And they started to call them killer bees because they didn't behave like ordinary honeybees. And of course, the domestication of these bees was a total failure. They are not domesticated. By 1970, they were all over Brazil. They got to Texas in 1990. And they've killed to this day over 1,000 people and about 100,000 cows. Anything that gets close to the hive, they go after. And that's what really makes the difference for these, is that domestic bees and African honeybees both defend their hive, but not just from things getting close to the hive, which is what these bees do. You don't even have to do anything to the hive. You just have to be near the hive and they will attack. So here's their spread from Brazil north. Luckily, though, because they are tropical bees, they cannot survive in the colder climates. They don't know how to hibernate in the winter the way that European honeybees do. So, so far, they have not been able to move further north to the more northerly states in the United States. But with global warming, that could change. So what makes them so bad? Well, they are far more aggressive than other bees at pursuing any animal that gets near their hive, whether it's a person or a cow or a dog or anything. They will aggressively pursue anything that comes even close to their hive. They will chase a person for a mile. So the people who have survived killer bee attacks are people who just started running and didn't stop. Just kept running. Once you get about a mile away from the hive, they'll stop chasing you and go back. That's way more than any other bees will do. Normal bees will never chase you like that. Going underwater is useless because they will just wait for you to come up. And there's been people who have tried that and then later died. Honeybees can be fatal. So an ordinary honeybee sting, about 300 stings is considered a fatal dose, depending on your body mass. It's people who've been attacked by killer bees have gotten thousands of stings. So they're extremely likely to sting, much more likely to sting than a European honeybee. So it's not the fact that the sting itself is that venomous, although they are a little bit larger. So here's the Africanized honeybee on the left, the so-called killer bees, and here's a European honeybee on the right. So they're a little bit bigger than a European honeybee. And here's a crew removing a killer bee hive. There was actually a guy in Georgia in 2018 who died trying to remove a hive of killer bees. So generally it's left to professionals. You can make some pretty good money removing killer bee hives from ranches and farms. And this just shows what happens. We had two things that happened together. We had a new mutation. So the bees were much more aggressive than other bees. They're even aggressive to local bees. So they find a new hive by killing the bees that are currently in that hive and throwing them out and then taking it over. So they're very aggressive to other bees as well. So highly aggressive and new environment, bringing over and creating a hybrid bee with African bees, and the combination that those African bees, one particular group of them, had a new mutation. So all the killer bees today are descendants of that one abnormal queen that was brought over. What about the murder hornets that we've just started hearing about here in 2020? And they are real. They're really called Asian giant hornets, and their species name is Vespa mandarinia. They do kill about 50 people a year in Japan, mostly farmers. There has been exactly one hive found in North America, in Vancouver, British Columbia. 2 individual hornets were found in Washington State, and that is as of this recording in May 2020. They probably arrived accidentally in shipping containers. Their normal prey are other bees. So normally what they do is they find a beehive, they kill all the bees in the beehive, and then they stay in there eating the bees and the larvae and the eggs for 4 or 5 days, and then they move on to find a new hive. Their venom is more potent than regular bees, and they have more of it because they're so large. They're about 2 inches long. You need medical attention if you get 10 stings, and if you have 30 stings, that's considered fatal. And compare that to 300 stings from a European honeybee to be fatal. So it is significantly more potent venom than from a European honeybee. And also, like all wasps and hornets, they don't die when they sting. So a single individual could sting you multiple times, unlike a honeybee, which loses their stinger. When they sting you, it's a suicide mission. They're going to die when they sting you, protecting the hive. But hornets can sting multiple times. So as we're trying to recreate diverse ecosystems, some surprising things have been discovered, and one of them was animals that were considered to be destructive to the environment, because just when you see what they do, it looks like they're wreaking havoc, like wild pigs creating a mud wallow and tearing up plants and eating young tree seedlings. It looks like they're damaging the environment, but somebody did a study in the 1980s where they actually compared areas that have wild pigs and areas that were fenced to exclude wild pigs. And it turns out that the wild pigs, even though it seems like they're tearing things up, they actually increase the biodiversity of plants. And in areas where pigs had been, there was actually more species of plants. Now, how could that be? So the pigs are rooting around, they're drinking water and then peeing that water out elsewhere. They're pooping all over the place. They're pooping out plant seeds that survive and then can germinate. So even though it looks like what they're doing is destructive, they are in fact not. And in fact, they are a natural part of the environment. And these chaparral woodlands that cover a lot of California actually evolved with pig-like ancestors, and they're adapted to it, and it's part of the ecosystem. It's also been found that buffalo and cattle, if they are allowed to free roam and not overgraze in one tiny area, if they are allowed to move around, they are beneficial as well for the environment, because buffalo and cattle drink water and then walk around urinating all over the place. They poop fertilizer everywhere they go. Many seeds survive their digestive tract and can germinate then. So buffalo and cattle, if they are free-ranging and are not confined to a small area, in fact are very beneficial to the grasslands. Grasslands evolved with large herbivores. That's part of their ecosystem, and it's beneficial to them. Beavers, which were destroyed in large numbers and extirpated from huge areas of the United States, have also been found to be very beneficial. And again, beaver activity looks very destructive. They're chewing down trees, they're damming up streams and creating big ponds and piling up these big debris piles everywhere. But in fact, in areas where beaver populations have been restored in the drier western states of the United States, they are hugely beneficial. They create a wetland out of what was a creek that maybe would go dry for the dry summer months. Now, with the dammed up beaver pond, water is there 12 months of the year for animals. So they increase plant life and they also increase animal life, and they provide an environment for fish and frogs and other amphibians that require year-round water. Wolves have also been shown to increase biodiversity. Wolves keep herbivores in check and prevent overgrazing by removing excess herbivores from ecosystems. And specifically, there was a study in Yellowstone National Park that showed that reintroduction of the wolves increased not just biodiversity of animals, but also surprisingly of plants. And it was good for the overall ecosystem to have a top predator in the ecosystem.